In this video, I'm going to be vibe coding with my new DGX Spark from NVIDIA. Over the past couple of days, I've had the chance to actually test the DGX out inside of my workflow, and I've also had the chance to be able to benchmark a few popular open source models on a new benchmark on BridgeBench.ai called the DGX Spark Bench. This is going to be a benchmark where we actually benchmark local models running on local hardware, and I think what better way than to use a DGX Spark for this. By doing this benchmark, I was able to create tests and tasks to put these models through, and it really has taught me a lot about the DGX Spark and about open source models, and I'm going to be taking this video to actually share those things with you. For example, one thing I learned is that you actually cannot cook an egg on a DGX Spark. You know, obviously when you initially buy a DGX Spark, that's one of the first things that you want to do with it is cook an egg, but that's actually not possible. But in this video, I'm going to show you everything that you need to know about the DGX Spark and about open source models. Is obviously these open source models are continuing to get better and better, and we are able to run better models locally on local hardware. So with that being said, if you have not joined the BridgeMind Discord community, this is the fastest growing vibe coding community on the internet. It's the home of the vibe coding movement, and there is a link in the description as well as the pinned comment below. And if you haven't already liked and subscribed, make sure you do so. Appreciate you guys. Let's get right into it. All right, guys. So the first thing that I want to show you is how I actually connect to the DGX Spark. So as you guys see behind me, it is running behind me on this shelf here. So if you guys are watching the live streams, it's always going to be back on this shelf. It's connected to Ethernet and it's running just right behind me right now. So to connect to this, I can just SSH into the machine, and I'm using NVIDIA Sync to do this. So this is NVIDIA Sync up here, and I just have to click connect, and it's going to quickly be able to connect to the DGX Spark, and you can see here that I can now launch it inside of Cursor, inside of a terminal, or inside of the DGX dashboard. So I'm just going to use Cursor here, and let's launch Cursor, and there's a couple things that I want to do to actually get this rendered correctly. You guys can actually see here that I set up OpenClaw using this DGX Spark, and it's now set up on this DGX Spark. More on that in a little bit later in the video, but let's just ask it what models are currently loaded onto this machine in Ollama. So we're going to launch this, and I am using Ollama right now. I know a lot of people will say VLLM, and I will be using VLLM. I don't know what your guys' thoughts are about that in the comments if you guys want to let me know. Obviously, I'm new to local hardware and open source, so anything that you guys can let me know in the comments would be greatly appreciated. So I want you to start up the Ollama, and I want you to start up WebView as well. And I actually think it may fail because it's not currently, so Ollama is not currently running, so I actually have to first start Ollama in Web UI, and then once I get that started, then I'll be able to, okay, they're already running, so let's see here, that looks good, okay. What models do I currently have downloaded on the machine, and which ones are currently loaded onto the GPU? So how this works, and I may be saying this wrong or not using the proper verbiage, so apologies there, but how this works is you can actually install the models. So you can see that these are all the models that I've currently downloaded so far on my DGX Spark. Qwen 3.5 122B, which is a huge model. I have DeepSeek R1 70B. I have Qwen 3.5 35B. I have Qwen 3. So Gemma 31B, I've actually already benchmarked that model as well. If you guys looked behind me, you could see that I benchmarked Gemma 431B. And this is really, really interesting to do because how this works is you download the model and then you can load them onto the GPU. So once you have them loaded, then they're actually available. So for example, let's just use this. Let's load Qwen 3.5 122B. I think this is one of the largest models that I can run on this hardware because the hardware, it's 128 gigabytes of VRAM. So I think the max model that I currently have downloaded is this Qwen 3.5 122B, and it's like kind of pushing it, right? So let's test this model out real quick. I want you to load this model onto the GPU. So we're going to load this model and see what we're able to do with it. We're also going to load and test out Gemma 431B because that just released like last week and a lot of people are talking about it. I was able to benchmark this model and so far I'm actually pretty impressed by it for an open source model. But let's load this onto the machine and let's actually start testing it and vibe coding with it. I'm over in BridgeSpace and now I'm just going to open up a new workspace and launch a preset of 6 open code terminals inside of BridgeSpace, and you can see here that I am actually connected to the Qwen 3.5 122B, the DGX Spark local model. So I'm just going to say, hi, how are you? So I'm going to say, hi, how are you? And this is going to be something interesting, like right off the bat here, that I want to show you guys that I've been experiencing, is that with some of these larger models, like this one, 122 billion parameters, right? I just asked it, hi, how are you? What I've been noticing is that some of these larger models run locally incredibly slow. Like this Qwen 3.5 122B model is going to run insanely slow. And we're actually not going to be able to test this model like in a vibe coding workflow because it's just too slow, right? And I think that this is a good example of that. So let's wait for a response back from that. And then after we get the response, we're actually going to switch over to Gemma 31B because that's another good model for us to test. All right, so look at this, guys. After 1 minute and 9 seconds, it said, I'm good, thanks. How can I help you today? So obviously, this model locally running on a DGX Spark is going to be very difficult for you to use if you're actually trying to use this in a vibe coding workflow because, hey, obviously, this model is running at very, very low speeds on a DGX Spark because it's very large and it's a reasoning model. It doesn't think very quickly on that local hardware, but this is what I'm seeing. Hi, how are you? Took 1 minute and 9 seconds to get a response, which is just absolutely absurd. So I just asked Cursor which one of these models that I have downloaded will run the fastest, and here's the list that it gave me. So fun fact, the larger the model, the slower it's going to run. So that model, the 122 billion parameter Qwen 3.5 model, that's going to obviously run the slowest. So I just loaded Gemma 4 latest, which is a 9.6 gigabyte model. And this one, we're going to test this and see how fast it is compared with that Qwen 3.5. But you can see here, smaller model size directly correlates with faster inference since there are fewer parameters to compute through on each forward pass. So let's now pull up BridgeSpace and let's actually get this model loaded and start testing it out. I just loaded Gemma 4 onto the Spark and we're now going to be testing, this is Gemma 4 latest, and let's just test it with the same thing, hi, how are you, and see the speed difference of running a much smaller model on the DGX Spark. So look at that, 5.3 seconds, so more than 10 times faster than that Qwen 3.5 model. But now let's actually start giving it some real world commands and start creating just like some HTML tests and see what it's able to come up with. I need you to create a single HTML file of a Retro Space Invaders arcade game in a single HTML file in this directory. Call it Retro Space Invaders HTML. So we're gonna do this, and we're just gonna, act like we would be vibe coding normally, but we're working on a bunch of tasks, right? I need you to create a single HTML file of a neon open sign in this directory, call it neon open sign. So you can see that this model is actually blazing fast on the DGX Spark. This model is working very quickly. Let's now go over here and drop another one. I want you to create a single HTML file of a campfire burning in the woods, call it campfire. So we're gonna do a campfire HTML and test that. You can see that this one just finished, so now this one's able to go as well. I want you to create a single HTML file of a lava lamp, call it lava lamp HTML in this directory. And what you guys can see here is that this one and this one, they're not really running at the same time, right? Like this one just finished creating the HTML and now this one's working. These two are still waiting. I need you to create a single HTML file in this directory of the solar system and the earth and the sun. It should be highly realistic, single HTML file, call it solar system. So we're gonna do a solar system one. Drop that one in. I need you to create a highly realistic first-person shooter game as a single HTML file in this directory. Call it first-person shooter. So do you guys see how this is working? Like, it's working on these tasks concurrently, and we're running 6 Gemma instances. But the speed that I notice, like with open source, is that I'm not getting an NVIDIA DGX Spark where it's like, okay, I'm now going to be using this in my vibe coding workflow, and this is my new way of vibe coding. But you can see, and we're going to see here in a second from the results, is what I'm wondering is, hey, are you able to run agents like OpenClaw, Hermes, Paperclip? Could you potentially be running these agents on an NVIDIA DGX Spark running these platforms and running these applications, and would it be reliable? I don't think that an NVIDIA DGX Spark, when you're comparing it to something like Opus 4.6. Obviously, you cannot compare open source models to frontier models. Like, it doesn't even come close. You're never going to be able to compare something running locally to a frontier model. That will always be the case. But what I will say is, if you guys have seen some of the news, let me actually find this real quick. Let me pull this up. GLM 5.1 open source. So you can actually run GLM 5.1 on a 256 gigabyte Mac Studio. And they actually said this, I don't know if I can find it, but they said this when they released GLM 5.1, that you can actually run this, you can run GLM 5.1 on a 256 gigabyte Mac Studio. And open source models are going to continue to get better. This Gemma 4 model here, we'll see the HTML files that it produces, because I think that gives us a visual representation of how good the model is, right? Like, I don't think that creating an HTML file is like too great, but you can see here, here's GLM 5.1 on Hugging Face, and they say that you can actually run this model on a 256 gigabyte Mac Studio. And I think that open source and local models that you're able to actually download and use locally are going to get better, and they're going to get to the point where you actually do want to have a machine where you're able to have that access to AI that's not just through a frontier cloud provider, right? So that's the way that I'm headed, where I'm going to be setting this up with OpenClaw, Hermes, Paperclip, and I'm really going to be putting this to the test. I don't think that I'm going to be using the DGX Spark in order to like vibe code my production applications, because the underlying open source models just are not good enough yet. And then this one actually asked me a question. I want you to decide, just build it for me. So this is already done. I will say this is actually pretty fast. This one's done. I want you to do this for me. The neon sign is created successfully. The campfire is created successfully. So the only one that's left is this one here. And then this one here will be finished up, and then we'll get ready to test this. But this is going to be 6 HTML files that we're going to be able to see the results of from a Gemma 4 running on an NVIDIA DGX Spark. Gemma 4 obviously came out last week, but we're going to continue to see better open source models. And I think it's important for us as people, members of the vibe coding community and members of the BridgeMine community, to be able to know, okay, this is where open source models are at, and to know that, hey, in the future, let's say that you buy a 512 gigabyte Mac Studio, which I will once the M5 Max comes out, you know, I'm going to be running some pretty serious models on that Mac Studio, and I'm going to be running them locally. So that's why I'm getting into this. I think that having a DGX Spark and being able to benchmark it on BridgeBench.ai and that NVIDIA DGX Spark Bench is going to be important for us to be able to understand, okay, this is where open source models are at, and this is what we need to know. Yes, make the changes now. So I'm going to come back to you guys and actually present what these are coming up with, and then I'll kind of talk a little bit about what I think and give you guys my opinion and thoughts on this. But it looks like these are all done, which is relatively quick. It's about under 5 minutes that these were all able to finish up. And if you look at the thinking, it's doing a pretty good job. So we'll see the results and make the judgment from there. But let's load these up and let's do a review. All right, here is the neon open sign. And one thing to note and remember about this Gemma 4 latest model is this is an 8 billion parameter model. And that is incredibly important to know. If you compare this to something like Opus 4.6, remember that Opus 4.6 is rumored to have trillions of parameters. So just remember that. But here is the neon open sign. This is what was created. Here's the first person shooter game. Literally like basically nothing. It's just a dot, and it actually wasn't able to create the game. Here's the solar system. It literally just created the sun and then like a ring around it. The Retro Space Invaders game, definitely not good there. Campfire in the woods. I don't know if that's a campfire, but I do see 2 campfire looking. So this is what an 8 billion parameter model will get you. And we're about to try GPT-OSS, which is a 120 billion parameter model. And it may be slow, but we're going to try that model that will be much larger and more capable. But you guys can see here that these results are not good, right? And this is Gemma 4 latest. And I'm pretty sure that this is a model that can run on your phone. These prompts that I gave it weren't that good, right? That they were just kind of like off the cuff prompts of like, build this, right? But if you gave that to something like Opus 4.6, I mean, we can literally see the results of this, if you go to BridgeBench.ai and we go to the UI benchmark, we can actually see how Opus 4.6 performs on this benchmark. So look at this. So Opus 4.6, here was this from Opus 4.6. Look at this. So this was the lava lamp produced by Opus 4.6, right? Like, that's pretty good. And if we go over here, we can see some of the other, like, look at the, here's the campfire that was created from Opus 4.6. So look at this. Like, this is what frontier models are creating. So when you do compare some of these frontier models, here's the open sign that was flickering on. Look at this. So here's the open sign, open. But like even here, there was still, it's not perfect, right? Here was the Retro Space Invaders game, and obviously this is from a Frontier model, so it's like, hey, that's going to be a lot different. Hold on, let's actually launch this and play it. Let's do Focus Viewer here. And this is on BridgeBench.ai, just as a reminder. But, you know, this is obviously like a workable game, and I think that this does show you guys just, hey, as they get these models larger with more parameters, they do become more capable. This is Opus 4.6. So let's unload that Gemma 4 latest model, and let's now load in GPT-OSS and see how that larger model is able to do on these tests. But you guys can obviously see, okay, these results from Gemma 4, which is an 8 billion parameter model, it was fast on the DGX Spark, but yeah, I'm not going to give that model access to like OpenClaw that has access over to my email, right? Because this is not good results from that model. So let's load a bigger model in and see how that one's able to perform on the DGX Spark. All right, guys, I have GPT-OSS 120B loaded onto the Spark, hooked up with OpenCode, and it's currently creating all of those HTML files. You can see it's running in BridgeSpace right now. You guys can see it just finished up this one, and it's going to work on these other ones. It's working on this one now. So I do see that this model is much faster than that Qwen 3.5 122. It was 122 billion parameters, I think. This one is much, much faster. And it's because I don't think that this is a reasoning model. I think that this is an older GPT model that is not reasoning. Let me just double check. I don't think that this is a reasoning model. Is this a reasoning model? Let me ask. I don't think it is, though. But we're going to let this run and see if a 120 billion parameter model is able to do better, and compare that with some of the frontier models. And it actually does have thinking capability listed. So I was actually wrong. It is a reasoning model. So this is actually pretty fast for a reasoning model then. It said it will produce a chain of thought reasoning before its final answer. So this one is now working. This one's done. This one's done. This one's done. This one's working. I'll come right back to you guys once these are all done, and we'll do a review. Here are the results from GPT-OSS. Let's load in this Space Invaders game. And as you guys can see, like, the Space Invaders game is much, much better with GPT-OSS than it was with, and look at that, even is accurate to when I get hit by a bullet, it says game over, right? So this is a lot more accurate than the Gemma 4 latest model. Obviously, that was an 8 billion parameter model. This one's 120 billion parameters. So this one is much better. Here's the solar system HTML file. You actually have Earth spinning around the sun. That looks better. The neon open sign also looks better. It's flickering. The lava lamp looks much better. And the campfire under the stars, same thing. It looks much, much better. So this, for example, this would be a model where, hey, for simple tasks like, hey, could I hook OpenClaw up with this with some really good instructions to be able to manage my email? I would say, yeah, you probably could. It was actually pretty fast. And if you go back to BridgeBench and we go to the initial results from the DGX Spark Bench, this is a very fast model. You can see the tokens per second from this GPT-OSS model are actually 41.9 tokens per second, which is pretty fast for a model that's running locally on your machine. So I will say this, is my first experience with open source models and local hardware. I'm sure that I'm going to learn a lot. So if there are any experts that are watching right now that are really good with this stuff, please drop a comment in the link in the description down below, in the comments down below, and join the Discord community so that you guys could, maybe help me with my journey here, because I think that open source is going to get better. And what's interesting is that the DGX Spark is actually not that powerful of a machine. You have 128 gigabytes of unified memory here. And yes, that's a lot. And the thing is, though, if we want to get to using more powerful models, we're going to need a better machine. And I will tell you guys this is the start of my open source journey. And once the M5 Studios come out, I will be buying a 512 gigabyte machine if I can. If they're available, I will buy one. And this is going to be my first experience, and I'm playing around to test, okay, how do you do this? How do these models perform? But in the future, we will be able to run Opus 4.6 level models locally. That is the way that things are headed. And I want people to understand that, like, frontier models will always be frontier models. By the time that we have a model running locally on our machine that's as good as the current Opus 4.6, we are going to have models that are like Mythos, that are just absolutely insane, running at 100 tokens per second, that are just blowing your mind, right? So open source and running locally on your machine is always going to be a step behind. But the thing is I do believe that with the right hardware, you will actually be able to get some really powerful models running locally on your machine. So this is the start of my journey with open source models. I'm going to be testing this out with OpenClaw, Hermes, and Paperclip. This was just my initial review, vibe coding with it, creating some simple HTML files with it. But in the future, we're going to actually be using this to create, some better things that are real world scenarios like OpenClaw. And we're going to be using this to actually create some mobile apps and whatnot. So stay tuned for that, but definitely go check out the new DGX Spark Bench on BridgeBench.ai. This is new. I'm going to be benchmarking new models on this every single day. But if you guys enjoyed this video and have any thoughts, make sure that you like, subscribe, join the Discord community, and join this journey. And with that being said, guys, I will see you guys in the future.